So we did chain reactions. Just kind of where you had one reaction, then you have after the first reaction, you have another reaction. Okay, that was what a chain reaction was. Especially, it was an issue with substances that had multiple oxidation states. So I'm going to do another. I'm going to do another reaction. I'm going to just tell you a shortcut as well for these reactions. I said let's do another one, which is जो कि बड़ा common है, ठीक है. That one is basically FeSO4 plus acidified KMNO4. अच्छा, FeSO4 plus acidified KMNO4. पहला काम किया, identify your reactants. So your reactants are what? Fe2 plus, and it's SO4 2 minus. There is K plus 1 and MnO4 minus 1. Acidified का मतलब है कि with MnO4 minus 1 you also have H plus 1. ठीक है. So these are your reactants, and I'm going to write all electrode reactions involving my reactants. ठीक है. तो उसको मैं थोड़ा working के लिए ना, for the sake of working, I'm just going to write it on the side. ठीक है. So I've got Fe2 plus. There are two equations. अगर तो data booklet in front of you है तो just open it. So there are two reactions for Fe2 plus. One, it's turning into Fe3 plus. Sorry, Fe. The other one is Fe3 plus gaining 1 electron, and it's turning into Fe2 plus. ये वाला मुझे पता है कि it's 0.77 volts. So then you have K plus 1. K plus 1 का वही, it's gaining 1 electron or losing 1 electron in equilibrium with K. That's I think minus 2.92 volts. Or here, there's MnO4 minus 1. So I'll just open the data booklet now. ठीक है, 1 second. ये data booklet, ठीक है. अच्छा, so MnO4 पे थे. MnO4 has kind of 3 equations, ठीक है. So what I'll do is I'll just लिखने की बजाय I'll just copy it here. ठीक है. So MnO4's got these. It's got these 3 equations. अच्छा, ये क्यों कॉपी हो रहा है, एक सेकेंड. ठीक है. अच्छा, ये 3 ये आगे, ठीक है. और कौन सी चाहिए? SO4 minus 2. ठीक है. I'm going to try and find equations for SO4 minus 2. So SO4, where is SO4? Something happening to SO4 minus 2. Losing, actually alphabetically है, ठीक है. So S would be probably on the other page. So I found one which is I found 2 actually. Both of them, they contain SO4 minus 2. So something is happening to SO4 minus 2 in both cases. अच्छा, ये भी उठा के ना मैंने यहाँ पे लिख दिया. So I guess those are all possible. So those are all possible electrode reactions, right? So I'm going to try and figure out the first reaction. The very first reaction is, I mean, out of all of them, I'm going to look for the highest potential. That's the one that's going to gain electrons. So highest concept, highest is this one. ठीक है. 1 point, sorry, yeah, Fe2 plus वाली कौन सी equation है? This one, Fe2 plus Fe3 plus. Let me just go and have a look of and find Fe2 plus. 1 second, where's Fe2 plus? ऐसे दोनों साथ ही हैं, इधर से कॉपी कर लेता हूँ. अच्छा ये हो गया. ये के वाली भी उठा के वहीं से उठा लेते हैं. ठीक है, that's my. तो ठीक है, इन सारों में the highest, so now out of all of these, the highest potential, the most likely to gain electrons is this one, जो मैंने mark किया हुआ है. And do I have my reactant? So it's got MnO4 -1 and H +1. So both of them are actually present over here in my reactants. ठीक है, तो I figured out who's going to gain electrons. ठीक है, initially. So this is the one that's going to gain electrons. And then I'm going to look for who's going to lose electrons. TK, that's going to be the lowest. So the lowest at the moment is -2.92 volts in Sarome, but I can't use this equation because if I consider this as the lowest one, then it's potassium that's losing electrons, and we don't have potassium. TK, potassium is not present over here. TK, it's not part of your reactant. So I'm just going to get rid of this. TK, so let's just ignore this. Acha, what's the next lowest? The next lowest are -0.44. So again, I can't use that. I mean, I can't use that because it's Fe that's going to lose electrons. I don't have Fe. Usko chhod ke, who's the next lowest? That's -0.04. Again, it's Fe that's losing electrons. I don't have
This
Fe.
is the wrong equation.
हाँ, ये दोनों गलत है ना?
No, we have Fe2 plus.
हाँ, तो इसलिए मैंने दोनों को रिजेक्ट कर दिया ना. Clear है?
But that equation doesn't have Fe2 plus.
नहीं, which equation?
The second one.
The second one, sir. One
अच्छा,
with the negative
ठीक है,
0.04.
हाँ ठीक है, वो है ही गलत. ठीक है, एक से इसको मैं उधर से उठा के ना, क्योंकि वही एक्चुअली असल इक्वेशन है. 1 second, where's the if अच्छा, it was the third one, this one. ठीक है, वो बाकियों को गलती पता लगी है ना, कि गलती ये थी कि this second one is basically Fe3 plus in equilibrium with Fe. It has nothing to do with our reaction because we don't have Fe3 plus, we don't have Fe. ठीक है, तो ये वाली उठा लेते हैं, ये इसके ऊपर ही मैं फिट कर देता हूँ. ठीक है, अच्छा, anyways, so this is the lowest, but I can't pick this because Fe is the one that's going to lose electrons. I don't have Fe. Pick on who's the lowest? 0.56. MnO4 -2 is going to lose electrons. I don't have MnO4 -2. MnO4 -1 hai. I mean, this is MnO4 -1. I don't have MnO4 -2 as well. 0.17 be the lowest. SO2 is going to lose electrons. I don't have SO2. ठीक है, इन सारों को हटा के finally the lowest I'm going to settle at is this one. It's 0.77, and it's Fe2 plus that's going to lose electrons, and I do have Fe2 plus as my reactant. ठीक है, तो वो clear है. बाकी सारी lowest reject हो गई हैं because I didn't have those things. ठीक है, and I ended up with Fe, I mean the second one. ठीक है, is this clear?
Yes.
Yes.
अच्छा, फिर finally क्या करना है? What you're going to do is you're going to pick इसको मैं अच्छा, एक ही साथ माइक ऑन है. चलो, अच्छा, फाइनली क्या कर रहे हैं, दोनों को ना इन दोनों को हाईलाइट कर लेते हैं. ठीक है, I'm going to make an equation out of these two. ठीक है, so it's going to be this one and it's going to be this one. ठीक है, one is forward, the other one is backward. Higher gains, lower losers. Fe वाली को ना I have to multiply it by 3 so that so that the electrons gain and lost are gain and loss are equal. क्योंकि यहाँ पे 3 electrons है, यहाँ पे 1 electron है, ठीक है? I need them to be equal. So I'm just going to add them up. So my reaction is going to be that it's MnO4 minus 1, ठीक है? Left side पे जो reactants है plus 4H plus 1. अच्छा, then ऊपर वाली equation में who's the reactant? It's 3Fe2 plus. और नीचे वाले में क्या? नीचे वाले में the product is MnO2. The other product is water. ऊपर वाले में product क्या है? The product is 3Fe3 plus. तो ये आपके पास है, that's your reaction number 1. ठीक है? So that's your first. अच्छा, so that's kind of your first reaction, which is this. अब ये कि moving on, what do we have in our container after the first reaction? और इधर मैं assume करूं कि let's say the FeSO4 is in excess. ठीक है? Let's assume that FeSO4 is added in excess. So what will my container have after the first reaction? वो container बना लेते हैं. ठीक है? So here's my container. अच्छा, it's still got Fe2 plus SO4 minus 2. लेकिन अब क्या कि अब products क्या हैं? The products are Fe3 plus. The other product is what? You also have MnO2. वो acid वैसे ही add किया हुआ था, water भी है, so there's H plus 1 which is acidified. The solution is acidified. Now I'm going to try and see. MnO4 खत्म हो गया, ठीक है? MnO4, let's assume कि it's limiting at the moment. So I'm going to try and see whether there's going to be another reaction after this one. तो हुआ ये कि MnO2 तो form हो गया. So most of my equations are going to be kind of the same. बीच में से ना I'm just going to skip a few equations. MnO4 तो खत्म हो गया, तो there's no MnO4. I think I would have to एक तो इसको pick कर लेते हैं. इसका कोई फायदा नहीं है, ये वो SO4 की वजह से, ठीक है? So this is kind of not that important. All MnO4 equations, I'm going to just leave them out. I'm going to go for MnO2 equations. So MnO2, if you look, after the first reaction, I have MnO2. So I'm going to see if something happens with MnO2. अच्छा, एक MnO2 ये हो गया. अच्छा, then where else is MnO2 involved? There's another one which is वही पुरानी वाली, it's this one. This one has MnO2 in it. अच्छा, this one has MnO2 in it. बाकी potassium वगैरह को कोई फायदा नहीं, क्योंकि it's the lowest, so I'm not going to write it because it's going to get rejected anyways. क्योंकि अगर वो add भी करोगे ना, तो it's the lowest, it's going to lose electrons. We don't have potassium. There is no potassium. We've got potassium ions, not potassium. So I'm not going to write that. Okay. I got Fe2 plus Fe3 plus. So I'm going to write equations involving Fe2 plus Fe3 plus. I think I'm going to include all 3 equations because in all these electrodes, there's either Fe2 plus or there's Fe3 plus. So I'm going to start finding, फिर से मैं clarify क्या करूँ, after the first reaction, MnO4 minus 1 got converted into MnO2. So I'm going to try and see, is there going to be another reaction with MnO2 now? So is it going to get further reduced? So if you look over here, again, who's your who's your highest potential? The highest potential is coming out to be this one. Ye wala. Okay, I think that's your highest potential. But we're not going to go for this because after the first reaction, there is no more MnO4 minus 1. That's been used up. Okay, so MnO4 minus 1 wali kahani khatam ho chuki hai, okay? So I don't have MnO4 minus 1. So I'm going to reject this. Who's my highest potential now? So that's 1.23. That's my highest potential. Or उसमें MnO2 की बात हो रही है, ठीक है? My container has MnO2. Because after the first reaction, my container had MnO2 in it instead of MnO4 minus 1. So that's my highest potential. And I'm going to look for my lowest potential, lowest concept, minus 0.44. Fe loses electrons, I don't have Fe. Minus 0.04, that's the lowest potential. Fe loses electrons, I don't have Fe. फिर कौन है 0.17 lowest potential. SO2 loses electrons, I don't have SO2. After that, who's my lowest potential? वो end में 0.77 आता है, ठीक है? So that's going to be my lowest potential. And Fe2 plus loses electrons, and I do have Fe2 plus still in my container. So this is the one that I'm going to select. ठीक है? और ये clear है सारों को?
Yes.
Yes.
और बस इनको add up करके ना you can make another equation. Make sure the electrons lost and gain are equal. So I think I would have to multiply this equation by 2 because यहाँ पे 2 electrons gained थे, so there should be 2 electrons that are lost. Add up the reactants. So the reactants are what? MnO2, 4H plus 1. नीचे क्या है? 2 Fe2 plus. And the product is going to be what's your product? The product in the first one is Mn2 plus. And 2H2, and नीचे जो product है, that's 2 Fe3 plus. So we have basically now figured out our. So we've now basically figured out our second reaction. Because after the first reaction, MnO4 minus 1 got converted into MnO2. In the second reaction, the same MnO2 then further got reduced to Mn2 plus. So there's a second reaction once the first reaction has happened. ठीक है? हुआ ये कि वो पहले Fe2 plus जाके it reacted with MnO4 minus 1. And then that same Fe2 plus then further reduced the MnO2 to Mn2 plus. So you clear a chain reaction?
Yes, sir.
Yes, sir.
This seem clear, Harun? Saleh, is this clear?
Yes, sir.
Acha, ab ye ke, so again, it's 2 reactions, right? So you're gonna make an overall reaction, which is sum both reactions up. ठीक है? दोनों का sum निकालो. That's so it's going to be reaction 1. Let's call this reaction 1, followed by reaction number 2. So the end result is if you do reaction 1 plus reaction 2. So this is so add up the left side. The left side is MnO4 minus 1. It's 8H plus 1. अच्छा 3 Fe2 plus ऊपर and 2 Fe2 plus नीचे, so that's 5 Fe2 plus. And the product is add up the right side, so it's Mn2 plus. How many Fe3 plus? 3 ऊपर, 2 नीचे, so that's 5 Fe3 plus. And there is 2 water in both equations, so that's 4 water. ठीक है? the MnO2 appears on both sides. जो दोनों साइडों पे, I mean, if I write MnO2 over here, it's going to be over here as well. So that's going to get cancelled out. So that kind of means it's not doing anything. ठीक है, it was just an intermediate that was formed and that was removed. ठीक है, वो पहले form हुआ MnO2, then MnO2 got, so anything that appears on both sides, you cancel it out. So finally, that's your overall equation, and that's a very familiar equation. Why is it a familiar equation? Ke it's often used in titration. आपका जो paper 5 होगा practical related things, this equation in titration, redox titrations, purple KMnO4 reacting with Fe2 plus, that's very common, and that's the reaction that happens. Like, to make this reaction, you would have to actually do 2 reactions, and then you would have to add them up. Is that clear?
Yes.
अच्छा, इसका shortcut ये कि at least for this reaction, because this is a very common reaction, if you look at the equations over here, I mean, basically overall क्या हुआ था? Overall, the MnO4 got converted into Mn2 plus, right? But we ended up doing it in 2 steps. Okay, पहले MnO4 got converted into MnO2. It was the highest potential, that's why. Then the MnO2 got converted into Mn2 plus. It was still the higher potential, right? So we did everything right. Again, fact क्या है कि the MnO4 got converted into Mn2 plus. So you could have not wasted time if you could just use this shortcut के जो MnO4 वाली equation है ना, what happens in this MnO4 minus equation is that every time when KMnO4 reacts, usually it ends up as Mn2 plus in 2 steps. So instead of taking this as the highest potential, you can just use a shortcut कि अगर पता है ना कि it's going to turn into Mn2 plus anyways. Why don't you just go ahead and use this equation that MnO4 minus 1 turns into Mn2 plus, even though it's not the highest potential. But we know that if Fazul ke na 2 steps karke na, you're going to end up with the same equation. So it's better ke whenever you have an MnO4 minus 1 reaction, just use this 1.52 volts, which is not the highest potential, but it will just save you time. You'll just get right. Because if in the end you're going to get Mn2 plus, why don't you just start with that equation? That's it. MnO4 minus 1 directly turning into Mn2 plus. So you don't have to do the extra steps. You'll automatically end up with the final reaction. ये बात समझ आइए, shortcut समझ आए? Is that clear?
Yes, sir.
Yes, sir.
ठीक है, ये क्योंकि KMnO4 बहुत important है ना, KMnO4 comes a lot. So in the paper you're just going to waste a lot of time. Just पहले वो equation बनाओ, फिर you make this equation, then you add them up. So it's just going to waste a lot of time. So just यहाँ पे मैं I'll just make a note. So most of the time it just ends up as Mn2 plus. So save time, use this equation for KMnO4. अच्छा, अब एक बस क्वेश्चन आखिरी कर लेते हैं, which is I'm just going to do it on the data booklet. ठीक है, I'm not going to waste time writing equations. ठीक है, let's try and इसको थोड़ा सा ना और short कर लेते हैं. This one is kind of lengthier, so it just kind of consumes a bit more time. अच्छा, the equation is where's iodine? अच्छा, so the equation is for iodine. ठीक है, let me चलो highlight हो गया. अच्छा, it's iodine, which is what, 0.54 volts. So excess iodine is reacted with vanadium. So where's vanadium? Vanadium is this equation. ठीक है, अब ये दोनों एक पेज पे नहीं आ सकती है, एक सेकेंड. तो vanadium की ना मैं सारी कॉपी कर लेता हूँ, इसको छोड़ देते हैं, बोर्ड पे आ जाते हैं. वो एक पेज पे नहीं है तो इनको उठा के अच्छा, so this is another reaction and I need the iodine one. अच्छा जी, so first thing, equation number 1, vanadium, ठीक है, you got this reaction, that's it. Iodine is over here. So the first, so we are only dealing with the first two equations. There's only one electrode reaction for vanadium and there's only one electrode reaction for iodine. So what will happen is iodine is the higher potential, so it gains electrons, and vanadium is the lower potential, so it loses electrons. And we're going to make the first reaction. So electrons balanced now, so it's vanadium plus iodine, and the product is going to be vanadium किस पे convert हो गया? It's turning into vanadium 2 plus 2i minus 1, right? So that's the first reaction. And after the first reaction, what are my products? My products are vanadium 2 plus, I minus 1 got produced, and there is excess iodine. Okay, so that's my first reaction. You clear the first reaction हो गया? Is this clear?
Yes, sir.
Or first reaction के बाद you got vanadium 2 plus, you got I minus 1, and there's obviously excess iodine, so there would be some excess iodine still left in the solution. अब आ जाओ second reaction. अब मेरा starting point जो है ना ये है. So vanadium 2 plus, I'm gonna mark equations which involve vanadium 2 plus. So I got this one. कोई और है vanadium 2 plus की? There's this one. And for iodine or I minus 1, it's this one. So again, who's the higher potential? It's iodine that's the highest potential. Who's the lowest potential? Lowest potential at the moment is minus 1.2. Vanadium is the one that's supposed to lose electrons, but in my products, you don't have vanadium. So I'm going to reject minus 1.2. The lowest कौन सा होगा? Minus 0.26. ठीक है? Even though ये मेरे starting point है ना, ठीक है? This is what has happened after the first reaction. So minus 1.2 I'm rejecting because I no longer have vanadium. Okay, so this is the reaction that's going to happen. So I'm going to construct the second reaction. Electrons balanced nahi hai. So this wali equation ko I'm going to multiply this equation by 2. So it's going to be reactants. It's iodine and vanadium 2 plus product here. It's 2i minus 1, or जो दूसरा product that's vanadium 3 plus. ठीक है? ये clear है? Second reaction हो गया. Is this clear?
Yes.
Yes, sir.
अच्छा, अब second reaction के बाद क्या बचा? Now you've got vanadium 3 plus I minus 1 has been produced, plus you still have excess iodine. So now I'm going to try and figure out what is the reaction that's going to happen between them. तो उसको फिर rub कर देते हैं. अब मेरे जो starting material है ना, that's this thing, vanadium 3 plus. So I'm going to look for vanadium 3 plus. Vanadium 3 plus is over here and over here, ठीक है? And I've got I minus 1, I2, so that's over here. Now again, I guess iodine is the one that's the higher potential, okay? So that gains electrons out of all these three. Achha, lowest कौन सा? Lowest is minus 0.26. Vanadium 2 plus loses electrons, but we don't have vanadium 2 plus anymore. So I'm going to reject minus 0.26. Who's the lowest after that? That's 0.34. So 0.34 is my lowest, and that works because I do have vanadium 3 plus, okay? Or the दोबारा से वो electrons gain and loss are not equal, so I'm going to multiply this equation by 2. So let's make the third reaction, which is ऊपर reactant I2 है. नीचे क्या? That's vanadium 3 plus plus H2O. Product के ऊपर that's 2 minus 1, and the next one it's VO2 plus. Plus 2H plus 1. So that's my third reaction now. I said, now what do I have in my solution after this one? क्या पड़ा हुआ? It's I've got VO2 plus now. I've got I minus 1 and I have excess iodine still. So अब एक आखिरी दफा दोबारा let's try and figure out whether there's going to be another reaction. So let's mark I2, I minus 1 TK, that's in the solution, and I've got VO with a 2 plus charge. So it's over here and it's over here. So अब मसला ये कि if I look for the highest potential, I mean, the equations that I'm talking about are these. I've got this one, I've got this one, and I've got this one. In तीनों में से I'm going to try and find out. The highest potential at the moment is 1. So VO2 with a plus 1 charge is going to gain electrons. I don't have this thing. I mean, this thing is not over here. So I'm going to reject this one. So इसको reject कर देते हैं. Who's the highest after that? That's 0.54. So that's the one that's going to gain electrons. TK, I do have excess iodine that's going to gain electrons, so that's fine. Then who's going to lose electrons? The lowest one, right? So the lowest one is at the moment 0.34. So V3 plus is going to lose electrons. I don't have V3 plus, so I'm going to get rid of that. Then who's the lowest? 0.54, that's the lowest. So I minus 1 is going to lose electrons. उसको भी reject कर देते हैं because I2 is gaining electrons. 1 will come out to be the lowest. Basic कहानी यहाँ भी खत्म हो गई थी. Okay, when I was looking for the highest, the same equation was actually coming out to be the lowest as well. So I'm just going to repeat this. When I was looking for the highest, 1 was the highest voltage, but I didn't have any of these. So they weren't able to gain electrons. Then it was 0.54, that was the highest voltage. I did have iodine over here, so it was able to gain electrons. But when I started looking for the lowest one, 0.34 was the lowest one, but I rejected it because I didn't have V3 plus. After that, I got 0.54 as the lowest. I minus 1 is the one that's going to lose electrons. So masla ye ho raha hai ki the one that's gaining electrons is the same as the one that's losing electrons. So basically, there's really nothing happening. So after the third equation, once you have these things in your solution, you get the same equation as the forward reaction. You also get the same equation as the backward reaction. So wo masla hoga ki nothing will happen. Reduction minus oxidation potential will come out to be 0 because it's the same potential, 0.54 and 0.54. So no reaction or no net reaction would happen at this point. So after this point, you don't have a further reaction. So is this clear कि यहाँ पे आके ना चीजें stuck हो गई हैं? They're not, nothing is happening after this. ये clear है?
Yes, sir.
Yes, sir.
सारा को clear है? सारा clear है? Tasneem, Salih, is this clear?
Yeah.
So बस ठीक है, just find out the overall equation now. So our overall equation is, I'm going to just add up all 3 equations. They're going to get added up. So when you add all three equations. It's what? It's अच्छा इसमें एक मसला हो रहा है. Where did this 2 come from? Your second equation में.
So I think you multiplied the equation by 2 because it was losing 1.
नहीं इसमें V2 plus V3 plus and iodine I minus 1. हाँ ठीक है. I did multiply this by 2. And we didn't. I said, was there a need to multiply the equation? I mean, the first one was this and this, right? So the electrons were already balanced. हाँ ये जो last one, this one, it was iodine was the one that's gaining 2 electrons, so that's fine. I said this equation had to be multiplied by 2. So I would have to multiply this. I mean, this one had to be multiplied by 2. I didn't do that. The water was also getting multiplied by 2. I minus 1 was fine. VO2 plus was getting multiplied by 2. And over here, I'm going to get 4H plus 1. वो मैंने add करते हुए ना add करते हुए I didn't when I added the reduction and oxidation, I forgot to multiply this by 2. So who's going to get cancelled out? The V3 plus are going to get cancelled out. What else? Yeah, I guess nothing after that. So it's vanadium plus 4 I2s on the left side. Plus there's plus there is 2V2 plus. Or right side pick here. I got V2 plus. I got 4I minus 1. I got 2 VO2 plus. अच्छा कुछ गलत हुआ इसमें ना ये. And I got 4H plus 1. यहाँ पे there was 2 water as well on the left side. As a balancing wise, I think, I mean, this V2 plus should not be here.
Wouldn't it get cancelled?
हाँ cancel out होगा लेकिन वो equal आने चाहिए ना दोनों sides पे. फिर वो completely cancel out हो जाएगा. I'm just trying to figure out why it's not. I mean, the first equation was between this and this, right? So it's gained electrons, 2 electrons, lost 2 electrons. ठीक है? तो वो ठीक है.
So
Second
there
equation.
might be 1 V2 plus on the left.
नहीं cancel out होने के बाद.
Yeah, after cancelling, so because there are 2 on the left, 1 on the right.
नहीं ऐसे में V2 plus exist ही नहीं करना चाहिए. If I remember correctly, the answer is that there is no V2 plus. Just one second. Let me. The second reaction was this one, iodine with this equation. So the V2 plus and V3 plus both got multiplied by 2. Okay, that looks fine. Okay, so that's kind of fine. Okay, that works. Third one is this iodine gained electrons, and so V3 plus got multiplied by 2. The water got multiplied by 2. It was 4H plus 1 and 2 VO2 plus 1. So everything kind of checks out, except that the V2 plus, इसको मैं जबरदस्ती cancel कर रहा हूँ. This is how I'm doing it. The V2 plus is definitely an intermediate. The intermediate should not come as in your final equation, because the vanadium got converted into V2 plus. In the next reaction, the V2 plus got converted into V3 plus. and then the V3 plus got converted into VO2 plus. So basically, when you add up equations, the intermediates should automatically get cancelled out. The overall equation should just tell you what happened overall. You started off with vanadium and you ended up with VO2 plus. Okay, the intermediates should all automatically get cancelled out. Like in this case, when I think zabardasti karni padegi कि I would have to multiply the first equation, I mean the entire equation by 2. Okay, and this one would become, so this one would become 4i minus 1. Now I can cancel out, वो multiply करने से कोई फर्क नहीं पड़ता. Like if you have an equation, you multiply the whole equation by a certain number, nothing happens to it. It's just balanced in a different way. So I just multiplied the entire first equation by 2. So when I add them up, there's 2v2 plus on the right, there's 2v2 plus on the left, so that gets cancelled out. The v3 plus signs, they also get cancelled out. हाँ तो इस तरीके से ना this is cancelling out. So the v2 plus gets completely cancelled out. Or इसमें ना so I'm going to get 2v plus how many i2s? That's 4 i2s. हाँ 4 i2 मैंने पहले ही लिखा हुआ था. अच्छा उस साइड पे it's going to be 4, 2 over here, 2 over here. That's 8i minus 1. ये गलत आ रहा था ना. अच्छा on the right side it's 2 VO2 plus. That's fine. There's 4h plus 1. That's fine. There's 2 water on this side. That's over here as well. हाँ ठीक है. अब वो all the intermediates are gone. ठीक है. Is this clear?
Yes, sir.
Yes, sir.
So 2 से मैंने, the only reason I multiplied it by 2 was I wanted to get rid of all the intermediates. अच्छा अब the other, so just remember these questions are going to be kind of rare. ठीक है. Most of the time when we do जब हम करेंगे ना pass web practice, most questions for KMNO4, just remember, just to avoid this whole chain reaction thing, never go for the 1.67 volts. Save time. शुरू में ना start with the 1.52 volt. ठीक है. Don't take that as the highest. Take this as the highest. So in that case, you would get rid of the whole chain reaction thing. ठीक है. So just remember, chain reactions are like not that frequent. वो जो शुरू में हमने easy वाले किए थे ना, these are the ones that are going to be frequently asked. Like SnCl2 with acidified H2O2, all of these. So I'm just going to end the equations, but Baki will do past papers and we'll talk about those equations once more. The next thing we're going to talk about is now the next thing we're going to talk about is non-standard electrode potentials. Remember electrochemistry में ना ये जो constructing the equations, it's not going to carry that many marks as well. Most of the marks are going to be वो जो start में drawings and stuff, so that carries a lot of marks. I mean, these equations part, I mean, this question when it came in the paper, right, this one, it was just a 2-mark question. That's it. लेकिन वो जब start में ना we did drawings, right, drawing the electrodes, etc., measuring electrode potentials, those questions are like 7-8 mark questions. तो equations के ना end में queries ज़्यादा है लेकिन इतने ज़्यादा marks हैं नहीं वैसे. So I'm going to do non-standard electrode potentials now. So non-standard by everything is exactly the same except that the conditions are not standard conditions. So this is what happens in a non-standard electrode. Remember, every electrode is in equilibrium. And according to Le Chatelier principle, the electrodes can sort of shift their equilibrium position. So the standard electrode potential for this one is minus 2.71 volts. तो बस ये इसको खत्म करते हैं. मुझे जल्दी से बताओ कि where would the equilibrium shift if I decrease the concentration of Na+1 ions? क्या होगा? लेफ्ट होगा, राइट होगा?
Left.
ठीक है, so it's going to shift to the left. Lee Shuttle principle है कि if you decrease the concentration, it will try to do the opposite. It will try to increase the concentration. अब Majda, if it shifts to the left, right? So electrode pe, will more electrons get produced or less electrons get produced?
More electrons.
ठीक है, तो वो जब equilibrium पूरा the whole equilibrium shifts to the left, right? So it's going to produce a lot more electrons. So on your electrode, more electrons get produced. And hence your electrode potential become more negative because you got more electrons now on the electrode. So electrode potential becomes lower. So your new electrode potential is going to be less than your old electrode potential. It's going to be lower. It's going to be more negative. But example ये कि अगर standard जो था ना not डला हुआ, that means standard. Standard was minus 2.71. That was under standard conditions. You decrease the concentration, the entire equilibrium shifted to the left. It started producing more electrons. More electrons got produced, so the electrode potential would be more negative. So instead of minus 2.71, it पहले तो ये not हटा देते हैं. Instead of minus 2.71, it might be minus 2.85 volts now. Idea clear है? Is this clear?
Yes.
Yes, sir.
So, the simple summary is if whatever happens, the Shatler principle basic equilibrium shifting to the left or equilibrium shifting to the right. If it shifts to the left or favors electrons, favors the production of electrons, then it's going to be more negative. If it shifted to the right, agar main kya karta, Na+1 concentration, if I had increased it, the entire equilibrium would have shifted to the right. And to wo phir electrons ko favor na karta, less electrons would be produced and it will become more positive in that case, ठीक है? Or it will become higher in this case. तो बस ये simple सा concept है, कल पे discuss करते हैं. We'll just talk about that, ठीक है? Tomorrow. कोई question नहीं है इसमें और कोई?
No, sir.
चलें ठीक है, कल बात करते हैं.
Sir, if possible, can you send the electrochemistry notes, sir?
हाँ मैं send करता हूँ, मैं कर रहा हूँ, अभी कर रहा हूँ, ठीक है? Okay.
Thank you, sir. Lovely, sir.